Okay, we're using a 6mm composite dual probe, 5 megahertz, coming to the outside diameter, section A, and we're going to scan from A to B. And we're going to smooth the couplant out here and try to scan smoothly and try to stay at the outside. Okay, so there's A to B. Now we're going to go B to C. I didn't like that variation of measurements. I want to make sure that it wasn't me, so I'm coming back. We're seeing the measurement drop a bit. There's an area here where I'm losing couplant, and that's mechanical couplant issue, so I'm just going to smear some more couplant on here. This couplant that I'm using is called high Z couplant. It's got a high impedance, and this is an interesting area here. Notice the variation in measurements. Let me see if I can repeat that. Yeah, there's an area there where it jumps a couple thousandths of an inch. Now going from C to D, again I'm going to smooth out the couplant. This couplant has a consistency of honey. It is the best couplant for ultrasonic transmission. And that was nice and smooth and even. That's what we're looking for. Some of that is how the probe is coupled, how the probe is handled. There's a little bit of skill involved, not a whole lot. Keeping the probe on track and evenly, having some even pressure. So that covered the next track. We're now at E to F. Start over. Okay, that completes that track. Okay, that's the next track. Now notice that we had I'm going back, I'm going to do that again because I noticed that there was a noticeable shift. Now we're doing G to H. Seeing that it's pretty even. And H to A. Okay, now we're going to go to the inner track. Goes A to B. B to C. D. Shifting a little bit for my own comfort. Okay, I'm at D. Back to E. E to F. F to G. Going back to G. G to H. Scanning slow enough, keeping constant pressure takes a little bit of getting used to. Once an operator gets used to it, I think they'll do a lot better than I am doing. Just getting the probe to just skate along the surface without raising it up. If you raise up the probe, you build up couplant underneath it and the readings are going to increase. So the probe has to be kept firmly down against the material. Just scan a couple of places from the outside in to see what variation we get between the OD and the ID. I will note that our calibration may not be exact because of not having appropriate reference standards. Our calibration is using shims of tungsten of known thickness over air. And obviously we have tungsten to moly. The difference is significant both in signal amplitude and in the phase of the signal. The phase of the signal actually reverses over the moly, so we have to change the gate setting from negative to positive when we go to the actual sample. Sectioning the sample, creating some actual knowns to calibrate to will improve the situation.